All right, so as you can see, today's lesson is solving a system of 3 variables. So this is actually a fairly easy problem because it tells us what z equals. So it says z equals -1, so we need to plug -1 in for z in both of our other equations. And then we're going to change that into a system of 2 equations. So substituting -1 in here, we'll have, that will turn into -5, this will turn into +14, because 5 times -1 is -5, and -14 times -1 is +14. Okay, so then I'm going to rewrite it as 12x plus 7y, and then I would actually add 5 to both sides, getting 21. And then here I would subtract 14 from both sides, and that would give me -23. Okay, so now if you notice, you actually have a system of 2 variable equations. So now it's just back like lesson 1 or 2, depending on how you solve this. In the notes, I solved it by substitution. If you are more a fan of elimination, by all means, you can use elimination here. And you would either multiply the bottom fraction by either 7 or 6, depending on which variable you wanted to eliminate. But to stick with the substitution, especially since the coefficient of our y term is 1, let's use that substitution method. And I will add 2x to get y by itself, leaving me with y equals -23 plus 2x. Okay, so now again, with the substitution method, remember we take this expression and we plug it in for y in our first equation, the equation we did not solve for. So we'll do that, and we'll have 12x plus 7, and then -23 plus 2x equals 21. So notice, this is the first equation, the only difference is I substituted that expression in for y. So now, we'll simplify and then solve. So we'll have 12x minus 7 times -23, and that's -161, plus 14x equals 21. And then I would add 161, and then combine these like terms. So 12x plus 14x is 26x equals 21 plus 161 is 182. And then I would take 26 divided by both sides, and we would end up getting x equals 7. So I now have 2 variables that I know what they equal in this equation. I know x equals 7 and z equals -1. So going again back to our original equations, you can plug them in and solve for y. So let's do that just like we did with 2 variable systems. So you can plug it in here to the 2 variables. So, or the original, doesn't matter because we know them both. So let's try here to these equations. I'll do the first one. So 12 times 7 plus 7y equals 21. Okay, 12 times 7 is 84. 84 plus 7y is 21. Subtract 84. 21 minus 84 is -63. Divide by 7. And we get -9. So our solutions, how we would write this, would be 7, -9, -1. That's how you write your solutions here. By all means, check your solution. There's a lot of places we could have made errors here, so check it in the original. So 12 times 7 plus 7 times -9 plus 5 times -1 gives us 16. 16 equals 16, that checks out. So let's try the second one too, just to be on the safe side. So -2 times 7 plus -9 minus 14 times -1 gives us -9. -9 equals -9, that checks out. So good, this works for both, so this is our solution to our system. X is 7, y is -9, z is -1.